Good afternoon and welcome back to the final event of the setup project for our thematic sessions. This morning we focused on policy changes and we have seen all the actions put in place by our six European partner regions in order to better support the smart grids at regional level. This afternoon, we will focus on two sessions, two thematics, self-consumption and storage, with a more technical approach. Only Franklin from Region, our advisory partner, will be the moderator of this session. Enjoy.
Perfect. Thank you very much for the introduction, Sara. So yeah, I hope you all enjoyed the morning session that we held separately from this, and I hope you've managed to have a chance to have some lunch and get your energy levels back up for what is an exciting agenda we have coming up of a whole range of different speakers. But first of all, quick introduction. Yeah, so I'm from Regen. We are an independent not-for-profit, I suppose, Centre for Energy Expertise and Market Insight based in the UK, in the southwest, in Exeter. And it's my pleasure to be the moderator today, to keep us to time, to also introduce some of the key topics that we're going to cover, collective self-consumption and also energy storage. So I will be trying to corral us through that area over the next hour and a half or so. So first of all, I'll very quickly say I hope you and your family are safe through these kind of quite tricky times with COVID-19. And if you are online now, please take a moment to introduce yourself on the chat. Perhaps there'll be a prize for the person that's furthest away from Rennes in Brittany, in France, where we were due to host this session. But please do use the chat function for that and engage as much as possible throughout the session. We're very keen to hear your views on two very interesting topics over the next hour and a half or so. And just on a personal note from me, a bit of a bittersweet session today. It's the final session over 5 years of the project. And as you can see from my flags, I'm personally I'm a little bit disappointed in the view of the UK to leave the European community, and I'll definitely always consider myself a European for the foreseeable, and setup's been a really important period of time over the last few years to kind of get to know the different regions and different areas of the European Union. So I'm definitely a full supporter of that interregional exchange that we heard through the Interreg Europe and from Charo earlier, and from the wider project partners earlier as well. So I will just move us on through into the slides. So as I said, please use the chat. That's what it's there for. It's a general discussion board. Don't be shy, as Sara mentioned earlier. Just put up some information, introduce yourself, where you're from, your organization, what you're interested in. Anything like that is very, very useful from our point of view. The Q&A function, or the questions tab that you see on the right hand of your screen, that's for specific questions for the speakers, and you can pop them in there and then uprate them if you think that's a particularly important question, which means it will go up in the priority list, and I'll be monitoring that throughout the session to try and pull it into the discussion and put to speakers throughout. So please do use that. We've also got a set of polls which I think are going to be live, if not live already. They are live already, so please do use that and interact in that way as well. We've hopefully got some interesting questions for you to answer in that. And the final point there is around sharing slides. So don't worry about scribbling down all the information that we'll have coming up on screen. We'll be sharing the recording, and obviously the slides are part of that recording. So the recording will be available after the session. Our agenda. So as I said, we've got a stellar lineup of different case studies or speakers on the two main subjects for today, which are collective self-consumption, a smart and local energy solution. Really interesting area that's being particularly kind of pioneered by Brittany. So we'll be hearing a bit more about them, and I'll do a quick introduction before that. The second session following that will be on energy storage as a kind of crucial technology for the enabling of smart grids generally, and for the enabling of the grid decarbonization. Very important technology, and we'll be covering off a couple of case studies from Andalusia in Spain, and also from the Algarve in Portugal. And I'll be introducing those speakers over the next few minutes, an hour and a half or two. And then we've got a bit of time for conclusions, plenty to get through, and I won't mess around anymore and get straight into the topics at hand. So, first of all, collective self-consumption. I'll just do like a quick 5-10 minute introduction to this area. So I think it's important just to try and outline broadly what it is. So the idea is, and actually Maximilian will be covering this as well in a minute from a kind of Brittany's point of view, but I'll take a go at it first and then hand over to him. So the broad idea is to try and share local generation. So that might be some rooftop solar PV on a public building like a school, or some other type of library or hall, and also potentially on people's buildings, individual buildings, and share that energy with others in the area. So I suppose the easiest analogy we've used previously is that you might try and buy your food locally and sell locally to local producers, but it actually can be quite difficult to sell your power locally. So why can't you buy and sell your power locally like you can buy your food? Like there's lots of benefits for doing that in the kind of local economy. So that's the broad idea, and that can be done quite easily on a kind of building scale. Or like in a site, so like a big factory complex or a commercial district scale, or it can be kind of a bit wider in like kind of more of a specific geographic area. So as it mentions there, consumers behind the same substation, or perhaps within a specific geographic area. I think Maximilian and Guillaume will be covering that in just a second. And so I suppose the key technology there is you need smart grids, smart metering is a crucial technology. So you need to know how much people are using it at quite a granular level. You need to know, and quite often, so a good amount of data on consumption. And you also need good data on generation, so you can try and line those things up and get the benefits there. The third point there is that it's been recognized in the EU Clean Energy Package legislation as and that's defined as jointly acting renewable self-consumers. So got some good legislation coming through from the European Commission. The benefits, so more local control. So as we've been covering this morning, kind of localized energy systems are going to be really important, and are really important, but are going to be continually really important in the smart grid future. And engaging local consumers in this transition, this really helps. These kind of models really help to communicate the idea. You can kind of see your neighbors' solar panels, or you can see the solar panels on your school, and you can understand that that energy is going towards your demand. It's a nice, powerful way of showing how this kind of energy system can work. There are kind of broader aspects to it as well. So we can kind of start seeing more renewable energy communities. Community energy is a really interesting area. So the idea that instead of individuals or businesses, you can pull together a number of individuals to kind of set up a community energy group and buy some generation, buy some solar onto a roof. That's a kind of a very active model and is very much promoted in the new clean energy package as well. So this is a perfect model for that kind of thing. Reduced energy bills for consumers, hopefully. So if you're buying locally, you might be buying at a lower price than you would be buying from the grid, simply put. Lower network costs. So I believe, again, Maximilian might be covering this in just a second, but the idea is you might be able to be charged less for the use of the network if you're doing this kind of localized collective self-consumption, and lower losses as well. So if you're generating and supplying or using locally, there's obviously a lower losses rather than taking it from the nearest coal-fired power station hundreds of kilometers away, or a nuclear power station 100 kilometers away. That kind of makes sense from those kind of areas. And in terms of the kind of EU picture, France seems to be a leader, and particularly we'll cover in Brittany, with a kind of a fairly strong legal framework and lots of pilot projects. It's quite difficult to find information on this. I'll hold my hands up, but this is a broad view of what I've seen from a bit of research. So there's a number of countries that have put together some kind of legal framework following the clean energy package definition, and they're listed there. But as I say, I think France is leading, hence why we're talking about it today. And then which technologies are, again, mainly I think solar based, but some other technologies like energy storage and some other kind of combined heat and power potentially in a few cases as well can be involved, but depends on the site and the community and the consumers that are involved. And finally, from my point of view, what's the role in the smart grid? So we're talking about matching demand versus generation in a much more coherent, joined up way, and monitoring that on a very granular basis, kind of second by second or minute by minute, rather than doing it over a year or a longer time period. That makes more sense, is a smart approach. So that's good for the network, good for the system. And as I mentioned earlier as well, it really engages consumers in this transition. It's a real tangible, practical way that they can get involved, either in kind of investing in those solar panels themselves, and benefiting from being supplied by using more or someone else's if they don't have a roof. So that's really beneficial. And supports local generation. So it supports the idea that we can get localized, decentralized, renewable energy sites up and running. And this is one of the models at the forefront of this kind of area that will hopefully grow and grow over the next few years. So that's a very, very quick high-level introduction to this area of collective self-consumption. I will now invite Maximilian onto the floor, and he will be kind of taking you through some more kind of a more kind of direct case study of this happening in Brittany. And thank you very much, Maximilian, for jumping in, because we've had a last-minute change in the agenda, and you've been very kind to jump into the fray and take us through it. So thank you for that. And I will hand over to you.
It's a pleasure. Thank you, Oli. I'm Maximilian Leman, in charge of renewable and smart grid energy at Brittany Regional Council, and I please excuse the director of our cluster at Lanson, who unfortunately fell ill, and I will ensure his presentation. I'm not an absolute expert, but I will try to describe a good overview of these topics with some reminders for participants who were present this morning. Sorry for that. If you can switch on my presentation, the slide 2, please, Oli. So, in introduction, to understand from 2010s and until now, we have been promoting the development of renewables and injection facilities in centralized grids. And after our state has taken over and defined an economic equalization framework to finance massification at the national level, and we pay that in our electricity costs. It was the first step to massify renewables everywhere in Europe. Then we also helped the first individual self-consumption projects to emerge. And this is still the case through regular regional calls, for instance, to agricultural target in particular. And finally, we observed, as I mentioned this morning, and you have remained just before, that the notion of markets and energy management at the local level could find an echo in with the concept of collective self-consumption. Producer, consumer, neighbors, together in a common new local green deal of low-carbon energy markets. There is a role, as you mentioned, only for energy system, but there are roles in markets and in acceptability terms, in involvement terms. And I remain, Brittany region have concluded its own action plan in setup project, and one consists in launching a call for ERDF project to support this first collective self-consumption loops. My colleague Guillaume will be explaining that just after my introduction. Collective self-consumption was already in its infancy. There is 5 years at the beginning of setup, but just at the scale of proof of concept. And we have seen the ideas of reducing consumption, the inclusion of all users, making full use of public electrical grid, led us to think about and to contribute to the first project of this kind, and to work with setup in this way. But works and concept of local community to share energy and collective self-consumption were also carried in a lot of many projects a little everywhere in France. And I believe you remain that in Spain, Belgium, UK perhaps. Not everything has yet stabilized, and support is needed to see the concept to the end. The first case is of real use of public-private investment and risk. It is also necessary, and we are helped and monitored by the Regulatory Commission in France and the main French DSO and EDIS to make sure that it can work, because the stakes are very high concerning the multiplication of the number of self-consumption sites. Just to stay in this slide, please, Oli. I know the time is counted. This raises many questions and challenges, and it's very important to understand that. The first one, it's how to preserve an economic balance on the global scale of public grids financing, taking into account of the number of autonomous sites is currently multiplied. How to preserve the role of solidarity played by the current electricity grid itself to guarantee the access and to evacuate an ever-increasing number of decentralized and variable production. How the public network can render services in different way without necessarily redesigning it. How to involve consumers in participating in conscious, in interested decision making about this deployment. How to turn it into a lever for concrete individual action for consumers who have been very passive until now, in fact. But also the last one, how to enable this initiative and this desire to share energy as one share local food production, for instance. Next slide. Here, as mentioned this morning, is not quite exhaustive schema of a collective self-consumption is a local community of energy exchange by contract within a local loop already equipped with common and first infrastructure. Firstly, a public infrastructure for the energy to circulate and to be rescued in case of a problem of storm, local blackout. And this is a fundamental point comparatively to individual self-consumption. Secondly, also, and this what makes it smart, a communicating infrastructure between the smart meters, existing smart meters, downstream of each building, but also upstream within each home. A service for exchanging data to control and beyond at the loop scale. And third, a partnership between consumer and producer, united as a co-ownership syndicate with a single person in charge of being the contractual link of responsibility towards the grid operator, the DSO in France. All the rest is made up of all the business model and combination of possible types of player which are currently the subject of economic opportunity studies in Brittany with SMILE, for instance. This is not very important because our network and the perspective regulated and deregulated model of electricity between our different countries are different, in the group are different, but I've put here the term of current French regulatory framework at the top. In the next slide, please, Oli. Sorry. I don't pass whole, but as you can see, this framework still limits many opportunities. Some are taking project to larger scale, but by asking the question of the size of premises and the meaning of the word self. So the word in self-consumption, what is the limit of local perimeters? The concepts of energy community promoted at the European level have not yet found their place in French law exactly, but whole communities are working on it right now. If you can pass the next slide. A small current picture of the number of smart projects that in Brittany and in Pays-de-Loire neighbor regions that integrate this market approach of local energy sharing or broad conception of collective self-consumption goes beyond the current electrical regulation reading. Multi-energy sharing, multi-public private networks, integrating smart mobility function, well beyond the photovoltaic perimeter alone. But in the law, in France, we consider only photovoltaics and a specific perimeter of 2 kilometers for loops. And this, as you can see, has been very, very strong success since we opened the regulatory door. And I hope that Europe is aware of this and will take it on abroad, I'm sure. So the last slide, please. just to say in all this, to finish my progress report, work in France is very accelerating barriers or being removed, and initiatives or multiply the local level, regional level, local community level is gradually becoming the norm for energy exchange, as was the aim of the first non-interconnected electric network at the beginning of the history, as close as possible to user on the societal and environmental aspiration and expectation. I have finished, and from now I leave the floor to my colleague Guillaume, who had the heavy task and the pleasure to instruct the self-consumption project in our call, ERDF call.
Perfect. Thank you very much, Maximilian.
Have any question that is?
We'll do questions in a moment after Guillaume's, and then we'll cover them then, if that's all right. Perfect. Guillaume, you have the floor.
Yes. So good afternoon, everyone. So within Setup project, Brittany's action plan was achieved through 2 calls for proposal funded by the European Regional and Development Fund in order to promote new models of energy use. First one was energy storage, which is not our topic now, and the other one was collective self-consumption. And those calls for proposal took place in a national and regional context. National context being that 3/4 of the electricity production comes from nuclear power plant, but the regional context is that the local production only covers 15% of the energy need. So there's a strong energy dependence in Brittany and a vulnerability to blackout. So the needs so smart grids are also a way for us to answer that issue. So as we just said, the collective self-consumption concept is an energy community where you have one or several energy producers together with one or several energy consumers. And they are gathered within a legal entity that represents its member in front of the network regulator and other energy providers and consumers. And even though within that energetic community, the energy is monetized among members, it is still considered as a self-consumption operation from an economic point of view. Still, when it comes to the legal framework, it's, as Maximilian said, it's quite restraining, because we cannot exceed, each loop cannot exceed 3 megawatts of installed capacities, and all members have to be located within 2 kilometers away from each other. But surprisingly, it's been quite helping us to fund those projects through European and Regional Development Fund credits, because from a state aid rule and competition law perspective, it's self-consumption, so it's a non-economical operation. And also, there are no market distortion because it's an operation that is purely local. So the models that we have seen through the project that we have selected on those calls that are located on the map you're seeing, they are really diverse, and I'm just going to present a few of them so that you may see how the wide range that you can achieve with collective self-consumption. The first project that is on the next slide, it's so an oasis, an electric oasis. It's a private-oriented project. It took place in an industrial and commercial area where companies and some, well, that could be industry, services, commerce. They are producing energy through solar panels on their roof, and their first and this concept, it's firstly individual self-consumption, and if there is a surplus, a production surplus, it is then injected within the collective self-consumption. So that's basically the specificities of this project. But it can be extremely different, like in the next project called Éclair, so it's ray of light in French, which took place in an urban area in Rennes. And it was carried by a consortium with an energy advisor company, but also another company that have been created and funded by citizens to support all the investment on energy production systems. And that project, it also includes a social pricing for potential poor households consumers that would have then an easier access to green energy. And that was the kind of project we were not expecting at all, but it still fits the model of collective self-consumption. Another project that is totally led by the public sector is the next one from a very small village called Le Sourne, of less than 2,000 inhabitants. But it was a very ambitious project of a collective self-consumption loop among all the public buildings within the village, but also a heating network among them. So all the energetic needs of the public buildings of that particular village were addressed through the project. And it's quite interesting because with that project, you see that smart grids, it's not only for big cities or big companies, it can also take place on the countryside with a very small village who has particular need. And those needs can be answered with collective self-consumption. So those three first projects, with those projects, collective self-consumption was the main objective. But on the next two, collective self-consumption was just an additional tool which is proving how adaptable the model can be. With this project, eFactory, the project carrier wanted to build an industrial building that could reach 100% of level of energy autonomy. But they realized that thanks to, well, within this building, there would be an energetic surplus. And they are just monetizing that surplus towards the neighbors. On the next level, we're still at the scale of one building in Lorient agglomeration, so on the next slide. Basically, Lorient agglomeration is the public authority for the city of Lorient and its suburbs. And the server rooms of all the local authorities are in the basement of one building. So the energy was clearly an issue for that buildings. But on the rest of the building, there were private companies. So the city who was owning the parking lots has put some solar photovoltaic panels on the parking lots in order to cover the needs of the collective self of the server room. But the additional production was sold to the private companies which were hosted in these buildings. And it has been a way, by using collective self-consumption, to make the project more profitable, the investment more profitable. So what we can see is that it's collective self-consumption. It's a win-win model, because for members of the energy communities, it's a way to monetize the energy that they produce at the current energy price and not at the publicly set price. But it's also interesting if you think further for the state or the public authorities, because it's a way for them to not have to subsidize the production of renewable energies through solar panel. And even more, if you have members of energy communities, they're selling energy to each other. So that could also mean somehow to more tax income on that production and that economic activities within members. And somehow it's also interesting from an EU perspective, because it means more competition on the energy market. So as a conclusion, I would just say that collective self-consumption is a completely multi-phased concept that can be interesting for a single building or on a broader scale. And each project that we have presented, there are many lessons to be learned from them. Sometimes they are addressing rather specific problematic, while on other projects there could be widely replicated. So that variety of insight, it's why the setup project have been for Brittany a very successful experience. Thank you.
Perfect. Thank you, Guillaume. That's an excellent overview of some of the key examples that you've gone through there. I really like the fact that how different the projects were. I didn't quite grasp how adaptable the model is, and the rural versus urban kind of differences there, and also kind of looking at the kind of how the resilience argument, which I think is one that's often forgotten. So I completely agree with you there. That's a really important area. So we've got a couple of minutes for some questions, if I may. We have had one question in through the question tab, so thank you for that. And the question is, how do you identify areas that are suitable for self-consumption, and how are these projects kind of identified, and what the best technologies? So if I go to Guillaume first, and then if Maximilian wants to come in afterwards, that'd be great.
Well, I would say that the main lesson I think we can learn from all of this project is that collective self-consumption is a very suitable answer to many problematics, but what is to be the important thing for each actor, each community, is to think about what are the energetic problematic that they want to address, and then collective self-consumption may be something to study or to push forward. But the main lesson is that the diversity of project is so wide that it's not one solution. It's actually one solution that could take place in one particular situation mainly. So how to identify areas? Well, first, what is your problem? And then maybe your area will be suitable. But I would reverse the question, actually.
Okay, no, that's a good answer. I like that. What is the problem? Maximilian, do you want to come in on that as well?
No, it was a good answer. We do not have a unique rule. We study the idea is not profitability but optimization. In fact, the right dimensioning of infrastructure and to involve citizens. We search the good model. It doesn't exclude the other models, as you said, you.
Perfect. Thanks, Maximilian.
And
I've got to follow up.
We wait the results. We have to make projects. We are at the beginning of the design of project. We have to wait 1 or 2 years of duration before to conclude.
To get to the results, yeah, and the findings and the learning and all that good stuff. Okay, one follow-up question finally, if I may, because we're running a little bit short on time, is so I suppose did you so the public-private thing was in there as well? Was there any differences between how it was kind of really public focused or mainly private driven? And I suppose were there any difficulties engaging those consumers to get enough consumers in, or one main consumer that is the kind of or producer of energy that is needed? Is there any learning there from Guillaume initially?
Well, actually, we were just asking if anyone had a project through our calls. So all that part, maybe that would be to the project carriers to be asked. But yes, I think mainly whether the project was carried by the public or private sector from an ERDF perspective, as I said, well, there's no, we can make the case that there's no incidence on the competition law. So it was actually a lot of work to prepare this argument, but once we've done it, we've just copy-pasted on all the projects. So we could demonstrate that there wasn't really any kind of distortions. So it was quite easy to avoid that question.
Perfect, thanks. And Maximilian, do you want to come in on that quickly? Or no, you don't have to?
Yeah, there was a difficulty specifically at the level of the management of each project. And we are thinking, we have any reflection between community collectivities, public authorities, of mutualizing the role of legal persons to represent each loops to facilitate and bring it more private individual new actors. We have to create an office to facilitate to communicate and to be more known.
Okay, great. Thanks for that. And we've had just one sneaky question incoming in last minute, which I will take because I think it's relevant. Do you see the limit in self-supply in the percentage of the total load? So is there kind of a certain percentage you're looking for in terms of collective self-consumption of the total consumption? And then another question is around the network fee, which I believe there is a separate network fee for collective self-consumption now, which is part of the beneficial framework you've got in Brittany.
So yes, on the network fee, yes, there is a special fee because you're still using the public distribution network. But as well, the model in itself implies that energy will be flowing from one member to another. So, well, it was a regulatory change that was required to help the system to be more profitable for the whole community. But on the first question. We were actually trying to initiate a new movement and to provide case model for energy collective self-consumption energy projects. So we were not really digging into the percentage of how much do you supply, or because actually what I'm just thinking about it, but I don't think that's really relevant, because if you may have, for instance, let's say just a hospital that would have huge energetic needs with many producers around, still that would just cover a very small amount of the hospital needs, but still it's renewable energy, so it can be worth taking it, and even though the supply coverage is rather low.
Perfect. That's excellent. Thanks for that quick answer. So yeah, hopefully that's a very nice whistle-stop tour through the collective self-consumption model, and hopefully those that have tuned in have learned something there, and I know I have. So thank you very much for that from Guillaume and Maximilian. Much appreciated, and very good presentations. Thank you for your time.
Thank you.
Thank you.
Great. So we will now move on to our next technology session, which will be looking at energy storage. So again, I'll be just doing a very quick run through in terms of a summary in a quick kind of 5 minutes, and then we'll be moving on to a case study first from Andalusia, and then also from the Algarve as well in Portugal. Right. I'll get cracking. So energy storage, what is it? Well, it's quite obvious, isn't it? So it's basically the battery cells we have in our laptops, in our phones, on a bigger scale, in our cars increasingly. So it's upgrading that to a kind of slightly larger scale and trying to use that as a storage for energy. It's increasingly important, as I mentioned before, in terms of the energy transition, as we move to more variable forms of renewable energy that are not dispatchable, i.e. we can't necessarily call on wind power when we need it all of the time, or solar power because it's not throughout the whole of the day, has kind of peakiness. So I picked out three main scales that we broadly define it here, and they are very different, those different types of energy storage solutions. So we've got the kind of domestic storage, which is kind of that very small image in the middle there. That is a Nissan X energy storage unit that has been printed with the Manchester City Football Club branding as a way of selling that energy storage product. So if you're a football fan, you can have your own personalized energy storage unit. That was kind of a few years ago. So that's kind of domestic storage. Commercial industrial, so that's kind of businesses, big factories, big refrigeration complexes that have very big energy needs. Storage can be used as a way of backup and as a way of kind of improving power quality. Sometimes that could be an issue as well. So it's a backup energy storage. If the power goes down or if there's an outage, then they have something to call upon. That's a kind of another area. And then we got grid scale storage, which we've defined as kind of 1 megawatt hour and plus. So that's really big shipping containers full of energy, full of cells, full of battery cells, and they're pumping in energy when we need it onto the grid and helping kind of balance the system, providing power quality services. And I think it's really important to note that energy storage is not just about lithium-ion battery cells. Lithium-ion is a dominant technology, but there are lots of other technologies, lots of other chemistries that are starting to kind of make way. And I've highlighted one here just on the screen, which is Highview Power, which is looking at liquid air energy storage as a kind of way of storing energy, but using the compression and the liquefaction of air through kind of like an established process, and they can doing that on a really big scale using established technology. And the UK's got a really good example of that, and I think there's one going on in America now as well. So yeah, not just the lithium-ion show in terms of energy storage. And the final point I'll just make on the Rubik's Cube problem is we use that as a metaphor to understand how to get energy storage going, because it can be quite a tricky area to understand, and there's lots of different areas in terms of the costs, which are changing quite a lot at the moment. Revenue streams, you might need to stack a few revenue streams together rather than rely on a feed-in tariff, for example, which you do in renewable energy, or some kind of consistent revenue stream. So there's quite a few things that need to come together for energy storage to work in the system, but increasingly they are. These main benefits of energy storage, I've kind of gone through a few of them already, so I'm not going to spend massive amounts of time here, but I suppose this is not necessarily the benefits, it's more the kind of services that they can provide. But classic case is kind of backup supply provision. So in an outage, you can have power and avoid going dark, or your production stopping if you're a factory or something like that. You can also, frequency regulation is kind of a very, very important one. So we need to keep the grid within certain frequency boundaries. If they go outside of those boundaries, there can be problems and things start to go wrong. So energy storage is really crucial technology in order to kind of help balance that frequency and maintain a specific frequency on the network. I won't go through the rest of them, but you get the idea. There's lots of services that it can provide, and storage is a crucial one within the smart grid area. Very quickly on market uptake. So This is not my data. This is from the European Association of Storage. This is their annual take on uptake across different areas. So residential being domestic storage, as I've covered, commercial C&I, commercial industrial, and then front of the meter, which I would class as big kind of grid scale battery. Very interestingly, that there was a dip in 2019. So it's not just a consistent growth pattern we're seeing across Europe. There definitely has been a little bit of a challenge, particularly in 2019. And I think from what I understand from that report was a couple of the leading markets, particularly in the UK and Germany, there were some policy changes around behind the meter, commercial industrial energy storage that caused that slight reduction. So it's not just a consistent growth pattern, I would say, over the last few years, but there's definite steps up in growth, as we've seen considerable growth since 2015 is the broad picture. And the final message I'll just convey now is this is a bit of analysis we've done on kind of future growth. So this is just the UK, actually. Sorry, I've taken this as a snapshot because I had it available, which shows kind of how much energy storage we have on the system in the UK. And as you can see, there's been small, well, fairly big incremental changes, actually, because the scale on the side of the graph is very big. But 2019 and 2020, there's been not a massive increase, but there's a huge pipeline and a huge amount of scoping, if you can see on those kind of shaded out bars, as well as the kind of the target for 2030 being very high as well. So I think that's a broad message that, yes, there's a fair amount on the system already, depending on which country you're talking about, but there's a huge pipeline of projects looking to connect and get on stream, get online over the next few years. And finally, sorry, I do have another final point before I hand over to the kind of specific case studies. It's a crucial technology into providing kind of flexibility and balancing on the system, and power quality services, which a lot of other technologies can't necessarily provide. So energy storage is absolutely crucial for smart grids in that regard. And a fundamental aspect of that is being able to deal with the variability of wind and solar in particular. And that graphic describes it. So we've got our solar peak in the middle of the day, and we've got the demand separately. So that variability needs to be sorted out by something, and energy storage can help with that, as well as demand side response. So moving demand, but we also need energy storage to move the energy and shift the power to times when we need it. So again, that was very much a whistle-stop tour of energy storage as I see it across the EU. We're now going to be moving into a couple of specific case studies from the setup project or from setup partners. I'll have to correct myself there. First, we'll hear from Hugo, and he'll be talking about some specific installations that they've done under a different project. And then we'll be moving on to Joaquin, who will talk about some of the kind of manufacturing and a specific kind of advanced battery materials manufacturing project they're looking at in terms of trying to get energy storage made locally as well as deployed locally. So I will hand over to Hugo. Thank you very much. Hugo, you're muted. And I'll control your slides.
Okay, thank you. Good afternoon, everyone, from the Algarve region, Portugal. It is a great pleasure to share with you our experience related to the implementation of battery storage in the Algarve region. We choose sharing this experience because it had a good influence and help from the setup project. Our participation in the setup project helped us to better understand the concept of smart city, of smart grids, and all technical and regulatory requirements for introducing storage in the grid. Next, please. Okay, thank you. In fact, this experience began and resulted from another European project, the storage project, which is co-financed by the Interreg Mediterranean program. This project involved a group of 9 partners from 7 different countries that worked together from 3 years to achieve their main objective. This objective has increased PV penetration in the energy mix of Iceland and the rural areas in the Mediterranean region by integrating PV and storage system under one optimal market policy by removing the constraints of grid reliability and also the res intermittency. In this project, our biggest challenge is to achieve high PV penetration in our energy mix through solving all market, technical, grid tariff issues without compromising stability or security supply. Next, please. But how we achieve this vision and overcome challenge in these areas? To begin, we need to investigate the effective use of storage with PV, considering all of its elements: PV, storage, self-consumption, energy management, and active prosumers. Then it was important to verify its real performance without the implementation of PV and storage pilots. More concretely, 35 pilots are installed in the set of 7 regions. More concretely, to testing grid connect, distributed storage combined with smart self-consumption and demand side management. Next, please. In the case of the Algarve region, 5 pilots are installed, all with the same domestic storage technical specifications. We opt for the Sonnen technology, in concrete with cells of lithium iron phosphate with 2 kilowatts of capacity, and the PV already existed on a self-consumption basis with 1.5 kilowatts peak. In terms of operation, the system constantly measured the energy production of the PV system. We can see the number 2, and the consumption in the household, the number 5. The energy surplus is stored in the storage system. In case the battery is already fully charged, the surplus is injected into the public grid. In the case of energy deficit, the energy is provided by the storage system, and if the battery is insufficiently charged or the need is much greater than the battery, the energy is supplied by the public grid. Next, please. Our 5 pilots are installed in the center of the Algarve region. Their selection is made out a context published in a regional newspaper. And now I will show in more detail the case of the pilot 2 from Albufeira. Next, please. Okay. Here you have some pictures. You can see the set of 6 panels and the box with the battery inside. We can see that the system is not a monster and is easily integrated in the household. Okay, next please. The implementation of the pilots made possible to carry out a set of very detailed monitoring operations. With the Sonan platform, you can consult on a daily, weekly, monthly, or annual basis the date you are measuring. In this case, we have the example of a summer day, more concretely on the 15th of July, and another more recently, 18th of November. We can see that in July, the purple line corresponding to the SOC stage of charge reached 100%, including surplus, which injected into the public grid. The energy storage during the day is discharged in the end of the day, as we can see in red. In November, the production is mostly absorbed by the installation, and the SOC is around 40%. You can see in this case, we do not take full advantage of the battery. Next, please. If you consider the set of pilots, Portugal, in terms of average self-consumption, is in a good position. However, the surplus is energy injected in the national grid represent around 15%. In terms of average self-sufficiency, the result is not so interesting. While in the case of Cyprus, Italy, or Spain, the energy consumption covered mostly by PV and storage, and in the case of Portugal, the PV represents 22%, storage 6%, and the national grid 72%. This result is strongly associated with the need to increase PV power to increase the economic system viability, and also the fact that there is a low on-trip efficiency of around 60%, compared with the supply indication 92%. Next, please. To finalize, I would like to share the main lesson learned. Overall, we conclude that battery storage can facilitate high PV penetration. However, with the price of storage still relatively high, a photovoltaic system without storage is more profitable to one investor. Another conclusion is the policy maker that want to encourage the use of storage system should consider the adaptation of existing exchange. To conclude, the optimal sizing of this hybrid system should take into account several parameters that include, for example, consumption profile, electricity cost, existing policy, solar irradiance and temperature profile, and in the end, technical related data of PV and storage. Thank you. Thank you.
Perfect. Thank you very much, Hugo. That's an excellent run through of domestic storage case study, and really interesting results. I love a graph of the discharge and the state of charge of the battery. As many of those as possible. That's brilliant. Thank you. Then we'll take questions just after Joaquin's session. So if you could just jump off your video, and we'll move on to Joaquin's session, and then race through some questions at the end. Fantastic. And a quick reminder, please do put in any questions you have to the speakers via the questions tab. And then also please answer the polls. We'll be very interested to hear your views on energy storage. And some of the challenges, as Sara has popped in the chat. So please do use those bits. Joaquin, I will pass over to you.
Hello. Okay, I cannot put the video, but I speak anyway. Yes, you introduced the energy storage as a very important element for more flexibility and balancing the grids. Also, the battery energy storage is one of the key elements. As you know, battery energy storage can improve the management of distribution network, reducing the cost and improving efficiency. Also can facilitate the market introduction of renewable, and this is important because we are seeing that the penetration of renewable energy is increasing a lot in the last years and also in the coming years. So it will be key to have this energy storage system in the grids. The energy storage is, as conclusion, is a key element to improve the energy performance of the smart grids. And this is precisely the focus of the setup project. So we could say that both projects has the same objective, but the approach is totally different. Setup is more oriented on improving regional policies, but the interregional partnership, is my presentation of today, is based on industrial side to try to invest, try to find interregional collaboration for innovative projects. So both initiatives are based on interregional collaboration, but as I mentioned, the approach is slightly different. Next, please. Yes, this is more or less the European battery network. There are a lot of initiatives, most of them coming from the European Commission, because Europe recognized that there is a tremendous market for the next year. It's estimated at around by 2025. Is estimated the market of battery in 250 billion euros. So there are a lot of competence from Asia mainly. So we have a very important automotive industry. So it's crucial to develop our own market, so own batteries, and that's why the European Commission launched a lot of different initiatives as a European Battery Alliance, the Battery 2030, the Batteries Europe platform. But at regional level, there's other initiatives as the Interregional Partnership of Advanced Materials. Next, please. Yes, the Interregional Partnership on batteries is part of the Smart Specialization Platform on Industrial Modernization. As you know, the European Commission is pushing regions to develop their own Smart Specialization strategy, and for that, they built many years ago, 4 years ago, a Smart Specialization Platform. There are mainly 3 platforms. The batteries, the partnership on batteries belongs to the platform on industrial modernization, but there are other partnership, other platform on energy, for example, or on agro-food. Next, please. Yes, this is the partnership on advanced material, or on advanced material for mainly for electric vehicles and energy storage on the grids. It was launched in October 2018. We start with only 8 regions, but right now we are more than 29 regions. The partnership is led by us, by Andalusia, and is co-led also by West Slovenia and Castilla y León. You can see in the map, there's a lot of regions from different countries. It's very well balanced and very well represented. And I would like to say that the partnership is still open. Any region that could that want to join to this partnership is open for the partnership is open for this region. You only need to sign a letter of intent, and you will be part of this initiative. And you can find more information in this link. Next, please. Well, what is the objective of the partnership? The partnership want to promote innovative investment projects based on interregional collaboration for electromobility and stationary energy storage. But this objective with this project, the partnership want to contribute to the modernization of the industry, want to accelerate the transition from the lab to the markets. The initiative want also to support the regional innovation ecosystem and reinforce the interaction between the industries, SMEs, research centers, universities, and so on. But at the end, we want to create this European value chain on batteries, as I mentioned, because we have a very big competence from other countries, mainly from Asia. And of course, we are, as a partnership with a lot of regions involved, we are very well connected with other initiatives as the European Alliance, European Batteries Alliance, or the European Batteries Platform, and another initiative at European level. Next, please. Yes, and this is more or less the type of project that we want to develop within this partnership. We want to start with projects that are not in the market with a technology readiness level of 5 or 6, and we want to achieve in a short period of time to have a project with a TRL of 9. This project must be industry driven. It's quite important the participation of the industrial sector. We have also to demonstrate the add value of the regional collaboration. That's why all the projects promoted by the partnership must have at least 3 member states involved. And as you can see in the slide, we have divided the partnership in 6 thematic areas covering all the value chain. We start from the raw material to recycling, also talking about advanced materials, cell, modules, pack, and application of these batteries. Next, please. And yes, we started in 2018, but we have already a pipeline of projects. You can see in the slide, we have almost more than 10 projects. We have 12 projects indeed, talking about different technology. As Oli commented, it's not all ion lithium batteries. There are other technologies, and we are trying to cover also these technologies you can see in the slide, but also testing centers, improving how the production of new batteries, and so you can see also the companies who are leading this proposal. So this is all from my side, but 2 main conclusions. As I mentioned, from setup project, we were collaborating between regions, trying to improve the policy regarding the smart grid. But I think that also is quite important, not only to improve the policy, but also to improve the industrial sector regarding the smart grid and regarding the batteries. And this is an example on how to foster the interregional collaboration to support the development of the industrial sector, bringing together regions with different capabilities, fostering the synergies between these regions, and that's why I think that it's a quite interesting initiative. The second key message for me is that this partnership is, as I mentioned, is open. So if you, as region, if you want to participate in this initiative, you can send us an email, and we will send all the information about the partnership and the procedure to join in this initiative. Thank you, Oli.
Perfect. Thank you much, Joaquin. An open offer there to join in that consortium or that project. Very interesting area in terms of trying to link manufacturing with deployment, which I think is so crucial, particularly as we look for kind of green recovery options and local jobs and all of those really important areas over the next few months and years. So yeah, please do take up Joaquin's offer there. Yeah, quick reminder, please do fill out the polls. I'll be going to them in a second. And if you've got any questions for the speakers, just chuck them in there. I'll be going to one of those in just one moment. So first of all, Hugo, Ugo, apologies, my pronunciation, terrible. One of the, I think, questions that came up was kind of how were consumers worried about having this kind of technology in their home, or was it quite an easy sell in this instance, in your example?
I think in our case, I think the contest had a lot adherence, and those consumers who have installed the system are very enthusiastic and check the platform regularity and are satisfied with the savings. So I think, yes, they are prepared.
Perfect, thanks for that. And you mentioned the sizing issue, or kind of sizing solar and the batteries differently. Is there anything else in terms of support required to try and help domestic storage and solar PV in the Algarve and broadly? What other changes might be necessary to really get that market going and up to the next level? Yes,
they require help. In this project, the size of the PV is one of the requirement of the select also to integrate the project. So they need to have a PV system up to 1.5 kilowatt peak, because the process of registration and implementation is simple. The size of the battery, basically we consider the parameter of the consumption profile and the market price. In addition, within the scope of the STORE project, one online storage optimization tools have developed and shared, which aims to calculate the optimal size of the hybrid PV and storage system in terms of the net present value of the investment.
Perfect, that's really useful. And a follow-up question to that, I suppose, on domestic storage was from Balázs, is can the systems, did you design the system so they can import from the grid, or is it purely using the solar PV from the roof? Or can you do both?
Sorry, I don't...
Sorry, and so it's a question, the storage system,
yes,
can it import electricity from
yes,
the network, from the grid?
Yes.
Yes, as well?
No, in this case, no.
In this case, no, but potentially.
Yes.
Excellent. So there's an answer for you, Balázs. Yeah, so that's a kind of a future option as well, is to kind of pull together a lot of batteries and then use them as a virtual power plant, or kind of aggregated together. A very interesting area. Potentially, we can cover that in another session. But Joaquin, I'll come to you next. There's a question in there from Arturas regarding redox flow batteries. So flow batteries generally, and whether they're included in your alliance, and whether they're included in your project.
Yes, it's a very interesting question. Yes, we have, as I mentioned, we don't want to focus on ion lithium batteries. We want to analyze different technologies, and specifically the redox flow batteries is part of our investment project that we are developing within the partnership. I propose that if Arturas is interested in this, to go to our webpage. You will see the type of project that we are promoting, but also we have one leading region of each thematic area, and one of the thematic areas is about rate of flow batteries. So they can contact directly with the region that is leading this area and try to propose some initiative or join to the initiative that are already running.
Perfect. That's excellent. Nice join up there. So hopefully you get another sign up for your alliance there. And also I'll just highlight there's a really interesting project in Oxford in England, which is looking to do a hybrid. So it's a 50 megawatt lithium ion grid scale battery, so quite large, and then also a redox flow, vanadium flow battery hybrid. Between the two, that's I think is one of a kind of only a few in certainly in Europe. So that's going to be coming online over the next few months in Oxford. So that'll be interesting. Those kind of hybrid solutions are a very a live issue, very interesting area that will be developed over the next few years. One more question from you for you, Joaquin, if I may. Regarding, so I really like the idea of linking in the kind of local manufacturing with the local deployment. Has there been any successes in Andalusia so far, or is it too early in the kind of process?
Yes, unfortunately, we don't have any initiative in Andalusia. We would like to have, and we are working for that. In the case of Andalusia, we have a very strong mining sector. We have also a very strong chemical sector, chemistry, and so on. And we have different companies working on batteries in the different elements of the value chain, working mainly at the end of the value chain with the application and so on. But we have a gap in this sense, because we have the initial phase of the battery with raw material, the last phase of the battery that is the application. But we don't have any initiative that gather all the elements of the value chain, and we would like to do that. So we are working precisely in have this initiative working in Andalusia.
Perfect, and that actually links quite nicely with a question that has come in as well regarding, are there enough raw materials to satisfy the global uptake? Perhaps if we take that down to a local uptake, so you've got the raw materials to satisfy some of the local uptake. I think the global question is still it's quite a difficult one to answer at this stage, because supply chains are really still getting going, and it's kind of a little bit chicken and egg, because if there's lots of demand, then there will be a supply chain. But in Andalusia, is there a good amount of kind of raw materials available, as you say, in the mining sector to be able to meet demand?
Or maybe not in. Yes, we have, as I mentioned, a very strong mining sector, not with lithium. Lithium is close to Andalusia. I think the second biggest mining of lithium is in Extremadura, very close to Andalusia. But we have other mining with other materials. But no, the question is quite interesting, because we will have a very large market of electric vehicles, and all of them will need a battery. And the question is, we will have enough raw material for that. As I mentioned, we are investigating, we are researching in different material, not only lithium, but it gives me this question left me to say that raw material is important, but also recycling is important. This is quite important, and also the legislation at the European level will be more unflexible in this regard, and request more and more recycling products to reuse these products. So I think that it's not about the raw material. It's about how to use well this material, and to design the batteries in a way that they can be reused or recycled.
Totally agree with that point. Really good point to end on, I think, there. Go for the kind of full circular economy. Recycling crucial in the energy storage market to make it a viable system, a viable supply chain. Thank you very much, guys. That was a really interesting discussion on energy storage. And apologies, we haven't got time to go into it. We could talk for hours, I'm sure, about this. But I think we've got to wrap up because I've only got a few minutes left. So thank you very much for your input. So concluding remarks. I think from my perspective, and if I might ask Sara to join the stage one last time. As I said before, potentially bittersweet after 5 years of the setup project. Hopefully you've had some useful insights over the last hour and a half or so across collective self-consumption and energy storage. I know I've definitely learned a fair few things there, and I think there's some really interesting models that can be applied across there, and some good learning on energy storage as well, and an offer there to join the Alliance. So please do follow up the Joaquin if you're interested in that area. And I'm attempted to follow the moderation from this morning. I've tried to follow Sara's example and managed to keep up with her, but we'll see. If I'm not sure if I've managed to. But Sara, do you have any final comments?
Sure, and Ollie, of course, you did an excellent work in moderating this session, and thank you very much for this expertise you brought to the project during these 5 years. Thanks, of course, also to our partners. I think that we saw that smart grid is a kind of complex word. We have technologies, we have models, we have consumers there, and of course, the need of funding all this and this transition. In this morning session, we focus on the role of policies and the main actions that have been put in place by the regional authorities. In this afternoon session, we focus on projects, and we saw that these main challenges related to technologies, new business models, and consumer involvement are really the same, and there is the need to have a kind of comprehensive approach to smart grid to succeed the transition in Europe. Probably two main lessons to take. One is the importance of the regional scale to really promote these new models and test it and validate it. Of course, with the collaboration of all stakeholders. And the other one is the importance of interregional collaboration. Setup is a perfect example of that. Interregional collaboration, both among policymakers and regional authorities, but also among innovation ecosystems, so among business or research stakeholders. So as the coordinator of this project, I really hope that this event was the opportunity to learn more about the role of regions in the deployment of smart grids in Europe, and that provided some food for thoughts for future projects and collaboration in your regions. So I just say thank you. Thank you again to our partners. This event was the result of teamwork. So thank you very much. Thank you, Ollie, for moderating this session. Thanks to Sara Banchi from Resolvo, always they're moderating the chat and the question session today. Thanks all for attending. We hope we will keep in contact and why not build future cooperation together. Thank you very much and have a nice afternoon. Bye-bye.